Hello and welcome to our next tutorial. In this tutorial I would like to show you how external controllers, for example PLCs or robot controllers, can be connected to Real Virtual. In this tutorial we are going to use a Beckhoff PLC which is programmed by TwinCAT, and you will learn how to connect Beckhoff PLC to Real Virtual I/O. For this tutorial I'm going to use one of the models of a tutorial we made before, but another way how we are going to do it in this tutorial is to use a real PLC if you have one. And here we are having a demo set up from Beckhoff, and thanks to Beckhoff for supporting us in providing this assembled demo rack. We are having here a PLC, the CX3D628C PLC, but you can use any Beckhoff PLC for this tutorial. And on this PLC there are several I/O modules attached to it, and there's test rack and test buttons for changing some of the inputs. You see here the inputs which can be set by the buttons, and we are going to use this for our tutorial. But as I mentioned, you can also use a virtual PLC which is part of TwinCAT engineering. There are two main use cases for connecting a PLC to Real Virtual I/O. First one is for doing virtual commissioning, so to test your PLC code before the real machine is assembled. This is reducing the ramp-up time and the commissioning time with the real machine, and it is delivering a higher software quality. Another use case where I see a lot of potential for the future is to provide a 3D HMI, how I call it. So to provide a 3D model with the real machine, and because Unity can be compiled to any of the destination platforms like Windows, executables, iOS, Unix, or WebGL, you could deliver this digital twin as a machine builder with the real machine for providing the user better understanding and more location information, for example about error messages. After you install the TwinCAT engineering environment, you should be able to start it, and it looks like that. For building a new project, I select here File, New Project, and I select this TwinCAT XAE project, and let's name it TwinCAT Real Virtual Tutorial. And after some time you should see here an empty project which includes motion parts, PLC parts, and I/O parts. If you've got a real PLC connected to it, something which is important is that here in the root to your real PLC is configured. Please refer to the Beckhoff online documentation how to create the roots. So you should see here your real PLC. I think if you install standard TwinCAT engineering with a virtual PLC, adding additional routes is not necessary. Here I can select now not local, which would be the virtual PLC on my PC, but if the root is added, I can select my real PLC, which is this one, as the destination PLC. Yes. So, because we are now connected to a real PLC, which might be, or which is for sure different, is the I/O configuration, what I've shown you before. We are having some additional I/O modules connected to our PLC, and for getting the I/O configuration of the real connected PLC, you can do here scan. Okay. So I don't want to import the COM port and the EtherCAT slave. I just would like to import the EtherCAT master, included the connected modules. So I just select for the moment this and OK. Yes. Yes. And now we are having here all our connected I/O devices of the real PLC. If we now, for example, select here this input, we can go to the real PLC and turn it to high and low. So we already have access to our real PLC, which is connected via this network cable to my computer with the TwinCAT engineering PLC programming environment. For our tutorial, we would like to program a very small program, basically just starting the drive and stopping the drive when the boxes are arriving at the sensor. For doing this, we need PLC code, because currently we still have an empty project just with the I/O device configuration. And for doing a new PLC code, I will add here a new item. And this would be a standard PLC project, and I'm calling it PLC and adding it to my project. And we are now here having an empty PLC project, including the main task, which is the main PLC code, which will run in a cyclic manner on the PLC. I can open this, and I'm directly in the structure text programming. And for the moment, we are going to define some variables here. So first of all, I'm going to define the sensor occupied and add any input. And this is how we need to write it, of type bool, and start drive symbol at any output, also of type bool. Now we can write in here our program, and the program will be very simple. If sensor occupied equals true, we would like to start drive equals false. So if the sensor is occupied, we would like to start drive. Okay, then is missing here, and I think, yeah, it's a little bit different from Unity coding. And if sensor occupied equals false, then we would like to start drive equals true. So if the sensor is not occupied, the drive should start. That's our program, and we can load it now to the PLC by selecting here activate configuration, and the program will be loaded to the PLC. It's asking if I would like to restart my TwinCAT system, the PLC, into run mode. I'm selecting OK. And we should see here that after some time, the light should get green, which means that my PLC code is now running on my PLC. Now let's get back to Unity. Within Unity, we are having currently, while it's running, this logic here. And we should turn this off because we don't want this logic to control it. Maybe the handling, yes, but not the conveyor. So we would like to control everything what's going on here with our PLC code. So now, as you can see, basically the conveyor is not stopping. Or what we could also do, just for the tutorial, because it's a copy, I just delete this. No, not this. The handling I would like to. Let's delete this logic. On the conveyor itself, let's see where it is. The conveyor is, I think, this one. Here we've got the conveyor and the drive. But the drive itself is not having any kind of I/O interface, and that's where so-called behavior models are used. And for example, I can turn with F1 this overlay menu on. If I'm on this drive, I get here with the yellow buttons some overlay, some behavior models. And for example, I'm adding here a simple drive. And the simple drive is a behavior model for the drive, which is giving me some standard inputs, PLC inputs and outputs for controlling this drive. And we'll use this, and we are going to use signals coming from the PLC for controlling this drive. On the sensor itself, there's already a signal connected to it, this sensor occupied, and I am going to delete this signal for the moment. So in the sensor there is no more signal connection, because also here the sensor signal will come or will be sent to our PLC. For now, adding a connection to our PLC, we select here under Real Virtual, Add Object, Interface, and here we are having all the interfaces. In this case, we would like to communicate with the TwinCAT PLC via ADS. That's the most simple communication protocol to our Beckhoff PLC. Another way would be to use TwinCAT HMI. This requires a special license on the PLC. The advantage of TwinCAT HMI is that it's a WebSocket-based communication, which is also working under WebGL, whereas TwinCAT ADS always requires that the TwinCAT ADS is installed on the PC. But here we can use the TwinCAT ADS interface. After inserting the TwinCAT interface, you will find it in your scene, and here you need to put in the net ID of the connected PLC. You can check the net ID in your boot manager, TwinCAT boot manager. So this is the net ID of my connected PLC, which is connected to my PC via a network cable. And I need to put this net ID in here, and usually it's port 851 you should use. After this, we can select here import signals, and we are going to get all signals in the project. So basically for the moment we don't need this, we can delete this, and we are having here sensor occupied and start drive as signals available. These are exactly the variables that we defined in our PLC program. Last thing, after importing the signals, what we need to do is we need to connect these signals to our behavior models. And we are having here our conveyor behavior model. So the start drive will be the forward bit of our simple drive behavior model, and the sensor occupied signal needs to be connected with our conveyor signal here. So we are dragging and dropping the sensor occupied signal to our behavior model here. So only thing we need to do, importing the signals and then connecting them by dragging and dropping, or by selecting them here with our model. So let's see if this thing is working, and we are going to start it. And yes, as expected, the PLC is stopping the conveyor as soon as the goods are arriving at our sensor. You can also check our model in Unity and our PLC code in parallel. So we see here that the sensor occupied is getting, so let's put it here, that our sensor occupied is getting true as soon as the package or the goods are arriving at our sensor. That's how we can use real virtual I/O and TwinCAT in parallel for virtual commissioning, so for programming and testing our PLC code. One important thing is that so far our variables in our program are not connected to any kind of I/Os. So our I/Os, which are in hardware on our PLC, are not connected to this input and output values of our code. For connecting it, we can select here, change link, and select, for example, on our first terminal, on our first module on the PLC, this first input. And for starting drive, we could create another link to our terminal output. You should always make sure that this not happens, what happens here, because our signals are connected to the PLC. So they are written from our Unity model to the PLC. But on the PLC side, we also have the signals written to the PLC from this I/O modules. And it happens what you see here, that basically we can control the drive with our switch here, and it's overwriting always the signals coming from Unity. So what you should make sure that if you're doing a virtual commissioning and if you are having real hardware I/Os connected, you need to make sure that your I/O devices, in this case, for example, let's check our device here, this terminal, this first module should be disabled. So now it's disabled. And if we now activate again our PLC, so we reload the code on our PLC. Yes, we would like to restart it in run mode. It's now restarting. So let's start here again, because communication error has been because of our restart. But now it works as expected, because our signals from the inputs and outputs are not connected anymore to the PLC, because basically we deactivated inside the PLC this first terminal or module. So please always make sure to do that if you would like to do virtual commissioning and if real inputs and outputs are connected to the PLC. What we can also do is to combine real input and outputs coming from our I/O modules or buttons, what we have here. And we can combine this with, I would say, the virtual outputs going to our real virtual model and the virtual inputs coming from our real virtual model. So far we deactivated this first I/O module, but we are still having this second one here with this button. And I would like to use this button for displaying operation mode by this light on this button, and for turning on operation mode on and off by pushing on it. We can also combine real and virtual input and outputs So what I did in our code, I added one more output and one more input, and this output and input should be from this button here. So when it's pressed, it's going to this second terminal, and the light of the button should get on when it's in operation mode. So I would like to turn with this wheel button the operation mode of the PLC, so the PLC program to running and off. And I've got here a detection of the positive flank. So if the button is pressed, so if it's going high, I'm switching from operation to non-operation mode, or vice versa. If the operation is on, the light should be on. And if the operation on, this code will run here. If not, I'm stopping the drive. I connected this button pressed and light button to the second terminal here, so to this one here. And I needed to deconnect our virtual for not getting any errors and for being able to load the program, including the hardware configuration to it. So now let's load it to the PLC. I'm going to activate the configuration, and I'm loading the configuration to the PLC. Yes, I'd like to restart it in run mode. So it's loading to the PLC, soon it will get green. So now the PLC is running again with our code. And let's directly start. And let's directly start Unity. Now Unity is on. Nothing is happening because I didn't turn the operation mode on. I can now turn it on and off. So pushing the wheel button will control our virtual model. It's now in operation mode, and my code is running as expected. So I've got now a combination of virtual inputs and outputs exchanged between the real virtual model and our PLC, and real input and outputs here connected to the PLC. I can use that, for example, for virtual commissioning if I've got real I/O devices, HMI devices connected to my PLC, but still some parts or more or less all the steel of the real machine is still in real virtual I/O. That's how I could use it. Or, for example, I could use it also if I would like to do, I would say, 3D HMI. So deliver a 3D model with the real machine connected to the PLC. So the 3D HMI within Unity, real virtual, will communicate over IOs or symbols, signals, which are not connected to any of the IO devices, whereas the real machine and real HMI is connected via this. That's it for today. I hope you enjoyed our tutorial. I showed you the first time how to connect real automation controllers to the model. So basically how to import signals on the TwinCAT interface and how to connect these signals to the behavior models within real virtual I/O. If you're already a PLC programmer, maybe something haven't been of interest for you. And if I did some mistakes or didn't explain it like it should be, the style and type of PLC programming, I'm sorry, I'm not a PLC expert, but it's enough, this simple PLC program, to show you how the connection between Unity and PLC, especially here between Unity and Beckhoff PLC, is working. Thanks a lot for today. Thanks for watching our tutorial, and have a lot of fun in using real virtual I/O and Unity, and see you maybe in our next tutorial. Bye bye.